A crucial issue in game theory is understanding the relationship between the different representations. Here, the relationship between the extensive form representation of a game and the normal form representation are investigated. The central concept in the normal form representation of an extensive form game is the plan. A plan of a player is a tuple that specifies one action for each information set of that player. Consider, for instance, player 1 in the picture. She has three information sets, 1.1, 1.2, 1.3. A tuple for player 1 is a triple specifying three actions, one per information set. For instance, suppose that the plan prescribes to play uppercase L1 at information set 1.1, uppercase R2 at information set 1.2, and uppercase L3 at information set 1.3. Thus, the plan is uppercase L1, uppercase R2, uppercase L3. In other words, the plan completely specifies the behavior of the player on the game tree. Consider now player 2. She has only one information set. Thus, a plan specifies only one action. Suppose that the plan prescribes to play lowercase r1 at information set 2.1. Given the combination of these two plans, we can identify the outcome of the game. In this case, the outcome is that one marked in blue, with the vector of payoffs 4, 4. Notice that every profile of plans identify univocally an outcome, unless the player nature is present. In that case, every profile of plans identify univocally a lottery over the outcomes. Starting from the notion of plan, we can define the normal form representation of an extensive form game. This representation has the classical normal form, a tabular representation, in which the number of players is the same of that one of the extensive form. The actions of the players are their plans. In the case of player 1, the plans are uppercase L1, uppercase L2, uppercase L3, and so on. That is, the plans reported in the figure. In the case of player 2, the plans are lowercase L1 and lowercase r1. Given a profile of actions, we identify an outcome and therefore the utilities of the players. Repeating the procedure for all the profiles of actions, we can entirely fill the tabular representation with the utilities of all the outcomes. While the number of outcomes is 5, that is the number of the leaves of the game tree, the size of the normal form representation is 16, that is the number of cells. So the question is, what is the size of the normal form representation with respect to the size of the extensive form? The size of the extensive form is equal to the number of nodes, including decisional and terminal nodes. Instead, the size of the normal form is the number of cells of the table, that is, asymptotically, as exponential in the number of the decision nodes of the players. This means that the normal form is, in the worst case, exponentially large in the size of the game tree. Now we can provide a formal model of the normal form representation of an extensive form game. It is the model of the normal form in which the set of players is the same of the extensive form. The set of actions is the set of the plans of the players. U prime is the set of utility functions defined on the normal form. Given the size of the normal form, that is exponentially large in the size of the game tree, the question is whether we can make the normal form more compact. Consider, for instance, action uppercase L1 and all the plans of player 1 that include that action. They are all the plans marked in orange in the picture. All these plans lead to the outcome 4, 4. In some sense, all these plans are equivalent. All these plans specify the behavior of player 1 at information sets that are not reachable due to action uppercase L1. It is the case of uppercase L1, uppercase L2, uppercase L3. Of uppercase L1, uppercase L2, uppercase R3, the same in this case and the same here. Technically speaking, we say that all these plans of player 1 are realization equivalent. That is, for every plan of the opponents, they lead to the same outcome. If this holds, the basic idea is to reduce all the equivalent, in the sense of realization equivalence, plans to a single plan. The reduced normal form is obtained exactly in this way. All the plans, including action uppercase L1, are reduced to a single action called uppercase L1 star star. We use the stars for all the positions in the tuple corresponding to the information sets that will never be reached. In this specific case, the second and third positions are never be reached due to action uppercase L1. The formal model of reduced normal form is the same of the normal form, except that some additional constraints are present over the space of the plans for the players. The space of plans in the reduced normal form is a subset of the non-reduced normal form, such that in the reduced normal form no realization equivalent plans are present, and for all the plans in the non-reduced normal form there is exactly one realization equivalent plan in the reduced normal form. The question is whether the size of the reduced normal form keeps to be exponential. And the answer is yes, as shown in the picture. Indeed, any plan of player 2 must specify one action per information set. Therefore, the number of plans of player 2 is 2 at z, where z is the number of information sets of player 2, showing us that the reduced normal form is exponential in the size of the game tree. Finally, focus for a while on games with imperfect recall. The goal is to show that the normal form is not a suitable representation for imperfect recall games. Consider the game tree in the picture. It is with imperfect recall. The normal form representation is that one reported in the picture. Specifically, since player 1 has only 2 information sets, her plans are tuples specifying 2 actions, 1 per information set. Focus on the utilities in the normal form representation. You can see that the utility vector 2, 1 does not appear. That is, it seems that it is not possible for the players to follow the sequence of actions uppercase R1, lowercase r1, uppercase L1. This is exactly what happens. Indeed, any plan specifying uppercase L1 for player 1 leads to the outcome 4-4. Any plan for player 1 specifying uppercase R1 does not allow the players to reach the outcome with payoff 2-1. This is because player 1 is forced to play the same action in both decision nodes of information set 1.1.